Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on air and combustion, and specifically we are going to be looking at competition for oxygen. Previously we looked at the reaction of oxygen with different substances. We talked about the reaction of oxygen with metals. We talked about the reaction of metals with oxygen, with nonmetals. So today we are going to see competition that occurs in regards to reaction of substances with oxygen. So we will start with the competition for metals, and we're going to be using the reactivity series for this session. So the more reactive metal will always take away oxygen from a less reactive metal. So when you put a reaction between a more reactive metal with a reaction of an oxide of a less reactive metal, this reaction can take place. There is no way a less reactive metal can displace or take away oxygen from a more reactive metal. And we are going to use this statement together or hand in hand with the reactivity series. The reason why this is possible is because the more reactive metal reacts very steadily or readily with the less reactive metal. So that's why it is possible. So these reactions are usually referred to as displacement reaction. We are going to break them down to single displacement and double displacement in the course of the session. So in Form 1, we'll talk about single displacement. Later on, in Form 2, we are going to talk about double displacement reactions. So some metals can displace other metals from their oxides. So we are talking about the oxides. So these metals that are higher in the reactivity series take away oxides or oxygen from metals in the lower level in the reactivity series. This means that you need to be able to remember the reactivity series well, just like we discussed previously. So potassium is the most reactive, followed by sodium, followed by calcium, followed by magnesium, followed by aluminium, followed by zinc, followed by iron, followed by lead, followed by copper, followed by mercury, followed by silver, and finally gold. So you need to be able to remember the reactivity series, and you can look for an acronym to do so. So let's look at some of the examples of these reactions. So an example, we are going to take a metal that is high in the reactivity series and an oxide of a metal that is low in the reactivity series. So an example of a metal that is high in the reactivity series is magnesium. Magnesium can comfortably take away all the oxides of metals below it. An example is zinc oxide. So magnesium can react with zinc oxide to form magnesium oxide. It takes away this oxygen to form, and zinc metal is formed. So the reaction in which magnesium is changing from magnesium to magnesium oxide, you can see there is an addition of oxygen. We said this reaction is called oxidation. So that addition of oxygen in magnesium oxide is what we refer to as oxidation. So, and then you notice our zinc oxide is losing its oxygen to form zinc. We usually refer to this process as reduction. The removal of oxygen from a compound is called reduction. So that is reduction. So let's look at another example. So we can react another metal that is on the reactivity series, like calcium. We can react calcium with a metal oxide that is low in the reactivity, like iron 2 oxide. So this reaction is going to form calcium oxide and iron metal. And you can see calcium, there is an addition of oxygen, and iron oxide is losing an oxygen. So calcium moving to calcium oxide is oxidation. while iron 2 oxide losing its oxygen is referred to as reduction. So when we look at these two examples that we have shown, the other thing that you need to remember is the observation that you see in this reaction. So magnesium and calcium are both gray in color. Zinc oxide is usually yellow when hot and white when cold, and iron 2 oxide is usually brown in color. If you look at the product, our magnesium oxide becomes white and our zinc becomes gray. Our calcium oxide becomes white and our iron goes back to gray. So you can see that change of color, and we say that these reactions are possible because both magnesium and calcium are usually high in the reactivity series in comparison to zinc and iron. So if you were to take a reaction or a compound that is below the reactivity series, for example, copper. So if you take copper and react it with magnesium oxide, this reaction here, the reaction of copper and magnesium oxide, is not going to occur. The reason why that does not occur is because copper cannot take away oxygen from magnesium since it's below magnesium in the reactivity series. So you'd say there is no reaction. So as we said earlier, the removal of oxygen is referred to as reduction, and the addition of oxygen is referred to as oxidation. So a substance that is going to lose oxygen during a reaction is said to be reduced. So it is losing, it's being reduced. And that substance which removes, the one that does the removing of that oxygen, is usually referred to as the reducing agent. And then a substance that gains oxygen during a reaction, we usually say that that substance has been oxidized, while the one that loses or donates the oxygen is called an oxidizing agent. So let's go back to the equations examples we had written before. We identify an oxidizing agent and a reducing agent, and also the substances that have been oxidized and the ones that have been reduced. So if you look at the first equation, we said magnesium is going to take away the oxygen in zinc oxide to form magnesium oxide. You see, we are starting with magnesium to form magnesium oxide. So we will say magnesium has been oxidized. But since it has done the actual action of taking away the oxygen from zinc, we are going to call it the reducing agent. So then our zinc oxide is turning from zinc oxide to zinc. It's losing oxygen. We can say it has been reduced. But also it has done the act of giving out its oxygen. It is donating that oxygen. So we refer to it as the oxidizing agent. So our magnesium becomes the reducing agent, and our zinc oxide becomes the oxidizing agent. Looking at our second equation, calcium is moving from calcium to calcium oxide. So you can see it is being oxidized. It is the one that is taking away the oxygen from iron 2 oxide. So we call it the reducing agent. And our iron 2 oxide is, you can see it's moving from iron 2 oxide to iron. It's losing the oxygen. So we say it has undergone reduction. But now, since it's the one that is giving out, is donating the oxygen, you refer to it as the oxidizing agent. So that's how you are able to recognize which is the oxidizing agent and the reducing agent. So a reaction where both oxidation and reduction is occurring at the same time, we usually call it redox reaction. So all the reactions we were discussing previously in the examples are all redox reactions. So let's look at one question to solidify what we have been learning. So an experiment on competition for oxygen was carried out, and Results were tabulated in the table below. Use the information in the table to answer the questions that follow. So there is a table below here. What is the order of reactivity of elements in this experiment? So we are going to do this slowly. First, we are going to look at the reactions. So first of all, you look at the elements. We have magnesium, carbon, lead, zinc, and iron. I know carbon is something we have not discussed yet. We might have to not use it in our answers. So we are going to concentrate on magnesium, lead, zinc, and iron. So when you look at the oxide, or the oxides are in the top, and then the elements are on the vertical lines. So magnesium has no reaction with itself, oxide of itself. Carbon also has no reaction with magnesium oxide, and then lead has no reaction with magnesium oxide. Zinc has no reaction with magnesium oxide, and iron. This tells you magnesium must be on top on the reactivity series. Next, magnesium can react with copper to form magnesium oxide and copper. Lead can react with with copper oxide to form lead oxide and copper, and zinc can react with copper oxide, and iron can react with copper oxide. This tells you that both lead, zinc, iron, and magnesium are all above copper. So let's put them above. So copper is below. So let's identify how they are now arranged. Then lead has no reaction with itself, and then zinc has no reaction. There's a reaction with lead, and it also has and iron has a reaction with lead. This tells you that both zinc and iron can react with lead oxide. It means zinc and iron are above lead in the reactivity series. So, but remember, lead is more reactive than copper. So let's put that in our answers. So next, we want now to separate between our zinc and our iron, which one is more reactive. So our zinc has no reaction with itself, with its oxide of itself, and iron has no reaction with zinc oxide. This tells you that zinc is above iron. So we have iron, and then we have zinc. So this is how the reactivity series looks like. We start with magnesium, zinc, iron, lead, and copper. So the reactivity is decreasing from magnesium to copper. So that's the final answer. So I hope you have been able to understand. So make sure you go with each and every compound to be able to figure out the answer. That's it for today. See you in the next session.